Yeah, so welcome everybody to our Agile BioFoundry industry day today. It's fantastic that you all are here, especially people that maybe might not historically be as familiar with the Agile BioFoundry. So my plans for the next maybe 15 minutes or so are to give kind of a quick overview of the Agile BioFoundry. Clearly, we are not going to have enough time to talk through everything, and I'm happy to follow up, or we as a team will be happy to follow up with you if you have any other types of questions. As Phil was mentioning, I'm the lead PI for the Agile BioFoundry, and I'll be giving the overview. So the overall goal for the Agile BioFoundry is to enable biorefineries to achieve 50% reductions in the time it takes them to develop bioprocesses compared to the current average of around 10 years. And the outcomes of what we're trying to do is to develop and deploy technologies that enable commercially relevant biomanufacturing of a wide range of bioproducts by a range of industrial hosts. And our relevance is that starting this year, we will be a $30 million per year public infrastructure investment that really helps US industrial competitiveness and enables opportunities for the private sector in terms of growth and jobs. And on this last point here, some of the things that we've been doing is trying to kind of position ourselves with the help of some analogies to the transportation sector. So I'd like to thank Katie Wozniak and Steffi Davison. I think Katie is on the call now. But for this kind of most recent iteration in our analogy visualization. So when the Agile BioFoundry was getting going, Lyft was doing a marketing campaign that largely had a map that looks like what you're seeing now, which has been further now adapted to the Bay Area regional transit map. So basically, if you're from or visiting the San Francisco Bay Area, this is going to look very similar to what the BART map would look like. And the way that Lyft was kind of positioning itself is it would say, sure, you might be able to take buses or the BART, subway to several different places, around the Bay Area, but where you actually really want to go to, whether it's home or work or to a restaurant, isn't exactly where that subway stop is. And that's kind of where Lyft comes in. So basically you would get off of the subway and then you can take a Lyft to get that extra mile. And we thought that was a fantastic analogy for us, because how we see ourselves at the Agile BioFoundry is we are this public infrastructure investment that gets companies fairly close in biochemical space to where they want to go, but we're not telling them where to go. We're not picking winners, and then companies can use all of their own business intelligence to figure out where they want to go and retain all the very valuable last mile intellectual property to get to the destination. But if companies work together with us, they don't have to reinvent the wheel. They can get a lot of the way to where they're going just by riding on our subway line. That's kind of the analogy. Couple of other little terminologies that we'll probably be throwing about today. So we have these terms around beachheads and targets. So beachheads are very analogous to the kind of the subway stops. So they're kind of intermediates that kind of get you along the way to where you want to go in metabolic space. And oftentimes a given beachhead can basically serve as an intermediate to many different targets, kind of the molecules where you want to go to, your final destination, where you'd want to be going to. So that's kind of like a layer on top of this map. And then another thing to point out is just kind of like there's maybe multiple different subway lines in the BART system. We also have overlaid onto this map this concept that different host organisms are going to be taking you to different places in biochemical space. So that's kind of maybe the different colored lines. So maybe Putida is going to be taking you kind of up here at top right, and C-glut is taking you to top left. Another kind of concept that we might be talking about a little bit are these exemplar molecules. So while there's a wide range of targets downstream of a given beachhead, an exemplar is just one example of an illustrative target molecule. So that's another type of a word that we'll be throwing about. Now, this is all through analogy. It's all very abstract, and I hope it helps you wrap your mind around kind of how we're positioning ourselves. So again, we really want to help companies, quickly develop processes to get to these target molecules. And part of that is developing these subway lines, these host organisms, and part of it is developing high flux kind of routes through these given beachheads. Now, in terms of something that's a little bit more specific and actually biochemical, I'd like to really thank Chris Johnson for adapting this map that was originally developed by Sang-Yup Lee and his group, but kind of showing here some actual chemical names in blue types of coloring. We would be having our actual target molecules where we've been developing demonstration projects to get towards them. We have the green are kind of our current beachhead molecules, and then in gray are for example, prospective beachhead molecules. So instead of looking like a BART map, the metabolic space is actually quite a bit more dense and more complicated. But this is kind of gives you a flavor for how do you kind of go from something that looks like this, like a BART map, to something that looks more like metabolic space. The other thing to point out here, I talked about the subway lines, the different host organisms, and maybe Pseudomonas putida can get you to the northeast, and C. glutamicum to the northwest on the BART map. But these are kind of these are our hosts that we've been working with in the Agile BioFoundry, and it's also just a kind of a super brief introduction to our tier system. So in order for us to even work on a given microbial host within our Agile BioFoundry, we really need to onboard them and kind of basically develop them to the point where we have a minimal set of tools that make them manipulable and cultivatable, those types of things. And that kind of those minimal requirements are really tier 1. So kind of fundamental tools and information needed for any kind of rational engineering cycle. And then as you progress up the tier levels, it's much more timely and costly to develop these capabilities, but they can really unlock some really powerful capabilities as well. So in terms of the hosts that we've been working with, currently in the bacterial space, we have Cupriovitis nectar, Rhodobacter spheroides, and Clostridium lungdalii. In the fungal space, we have Leucomyces starkii, Aspergillus pseudoterius, and Zymomonas mobilis. Now, those are just to tier 1. Hosts that we've also further elevated to tier 2 would include on the bacterial side Pseudomonas putida, C. glutamicum, and on the fungal side we have Aspergillus niger and Rhodosporidium toroides. So these would be our current subway lines, and maybe some of these are kind of maybe darker, thicker lines with more capabilities, and some of these other ones are kind of the earlier stage in terms of our developments. But I hope that's kind of helpful to people to see, like, are the hosts that we're working with the hosts that you're also working with. And we're definitely interested in working together with industry and academic collaborators to increase the number of organisms that we're working with. So if you don't happen to see your organism here, it's an opportunity for us to work together in the future. And I'll give you kind of somewhat of a timeline for how we see the expansion in the number of hosts that we're working with. Other things to kind of point out, maybe I'll kind of introduce this going back to the simple map. You can imagine that if you're a city planner or a regional transportation planner, you want to figure out, okay, there's a whole bunch of potential new subway stops, maybe underserved communities, these types of places, or maybe for the economy, you kind of want to know, if there's a lot of people trying to access this point, maybe it would really increase the economy of the local area if we introduce a subway stop there. But how do you actually decide where you're going to be siting that next subway stop? So maybe if you're actually in transportation, you'd be looking at transit flows, demographics, all the types of regional economy types of aspects. Kind of the analogy for us is doing things like techno-economic analyses and life cycle assessments. And I think some of the really exciting things that the Bruno Klein and Tatiana Benavides have been working on have been, how do you actually do these types of analyses, not for a very specific process or a very specific product, but how do you kind of do it to capture kind of the techno-economics or the life cycle assessments of a general region of biochemical space. And that's how they've been kind of doing it through these exemplar molecules. So there's a lot of targets that you could be going after. Maybe that would be the analogy to a lot of potential restaurants you could be going after. But maybe instead of analyzing every single possible target that you could access from a beachhead, just represent it in an exemplar. And I think this is really going to help us prioritize, going forward into the future, like where do we develop, our host organisms, our beachheads, our pathways to best serve and give the best access to opportunities in biochemical space. So maybe in the techno-economic side, you can kind of see, what is kind of the incumbent, minimum selling price or market price for a given product. Given what we know about our bioprocess, where are we? Are we actually bioadvantaged? And then same thing can be true for the life cycle assessment. So in terms of greenhouse gas emissions, for example, how might we be doing relative to a fossil feedstock? So this would be some of the other kind of things that we've been working on to figure out how to cite like our next beachheads or choose our next host organisms. The general approach that we follow, we do kind of follow the general engineering biology cycle, going from design through build, test, and to learn, and then back into redesign. I already talked a little bit about some of the techno-economic and life cycle assessments, talked about some of the hosts that we're working together with in the tier system. And then I'll be talking probably after this overview talk a little bit more about some of the capabilities specifically around design, build, test, and learn, including scale up. So this is kind of generally the process that we're trying to use in our approach that we follow at the Agile BioFoundry. And this gets into a little bit of the timeline. So maybe when the Agile BioFoundry was first getting stood up around 2017, the average bioprocess might have taken about 10 years to commercialize through scale up at a cost of maybe around 100 million US. And in our first 3 years, the Agile BioFoundry, as we were kind of ramping up, we said that we were going to be operating with 5 hosts by the end of the 2022. So about a year from now, we'll be up to 15 host organisms. I listed 10 on the previous slide. And we do anticipate now that we've started to see some shaves off on the development time and the development costs. And where we kind of want to be after, say, 4 more years from now is getting up to increasing numbers of hosts. We're having some interesting discussions in industry and academia are really helping us think through this. But how do you balance going deep in a given organism versus trying to diversify your hosts? So in the transportation analogy, do you really want to work a lot more on developing a given subway line, or do you want to expand into more subway lines? So I think we're still trying to figure out, do we want to go this broad, or do we want to go a little bit more deep in some of our hosts? And it's by the end of our 9 years of our projects, which would be about 4 years from now. That's kind of when we see, if a company works together, with the technologies that we've developed with the hosts, with the routes through beachheads, that's really kind of help new companies shave off 50% of their process development times. Now, in terms of the actual task that we're doing, and we've talked about some of these things already. So we've talked about some of the techno-economic analysis, life cycle assessments, host onboarding and development. We'll see some more of the scale-up capabilities on a slide here in a few minutes. Phil was referring to industry engagement and outreach, which is really important, especially for events like today. We do have a regular management. And one thing I'll just kind of point out is that in our core engineering cycle activities, we do have folks that are working on kind of our core infrastructure. And we do have some people working on kind of the beachhead developments, as well as demonstration projects to kind of show that not only do we say we have these capabilities, we've actually used them, and here's what we've done. And a lot of these demonstration projects increasingly are actually just getting done in collaboration with industry or collaborations. So over time, more of our internal efforts have been focusing a little bit more strategically around these beachheads, and the demonstration project largely are starting to transition more to our collaborations. Just to throw up our organizational chart, just to point out, especially on days like today, we do have an industry advisory board that we meet with on a quarterly basis. But days like today, that's more open and inclusive beyond just our industry advisory board are also super important for us to kind of get feedback, as well as just to understand and meet and greet and business development, try to understand who else could we be working with or helping or learning from. So that's why I kind of throw that up there. Now, another kind of key thing just to be aware of when we talk about the Agile BioFoundry is that we are distributed across the US. We're not just in one single location. But together we draw upon all the capabilities, the infrastructure, the domain expertise at 7 of our US Department of Energy national labs to form the Agile BioFoundry. And another kind of important thing is that while we're working on these demonstration projects, these collaboration projects, that can develop processes for going after fuels or chemicals or materials. We're also developing a lot of technologies. That could be software, it could be automation, it could be workflows, it could be genetic tools, all kinds of different things. And one of our core philosophies at the Agile BioFoundry is that any technology that we're using, especially during a collaboration project with industry or academia, those should be technologies that a given company or an academic can actually license off the shelf from a commercial company or license from us, so that they can practice those same tools and capabilities at home in their own organization behind their own firewall. So that's maybe one way of differentiating what a place like the Agile BioFoundry does, rather than maybe some of the more commercial biofoundries, where you might have a fantastic experience working with them, but you're probably going to want to go back to them as opposed to trying to repeat what you did with them in your own foundry, because you're probably not going to be able to bring in all of the same techniques and tools that are being practiced at a commercial biofoundry. Some other little things, and maybe this is a little bit just budget wonky, but I think it's actually pretty relevant for some of the people on the call to understand kind of how our budget and our resources are getting allocated, and how does that directly impact future types of collaborations. So the first thing is, for the past, say, 5 years, we've operated at a $25 million budget. So we, sorry, at a $20 million budget. And then in the congressional, budget language, we're anticipating our budget is going to be for fiscal year 2022 up to $30 million. So that's a bit of a change from us. And the way that we're breaking this down is we're going to be doing 23 on kind of like internally directed projects, and we're setting aside 7 million for collaboration projects. Now, that could include things like directed funding opportunities, and I think you're going to be hearing more later today about these directed funding opportunities. And 3 million of the 7 will be going into kind of the kind of what we've done in the past, these open directed funding opportunities that anybody can apply for, and I think you'll be hearing more about that later. But we've also been, prioritizing some of these resources for doing collaborations with others as follows. So we have been setting aside or prioritizing $2 million to collaborate with BioMade, and kind of the concept here is that BioMade could be supporting kind of its members and its participants. And the Agile BioFoundry would be using $2 million of our budget to work on our side in collaboration with BioMade. So I mean, just spend a little bit of time on this, but BioMade has been focusing and situating itself in slightly higher manufacturing readiness levels, say for example levels 4 through 7. But often in those projects, you will encounter kind of lower technology readiness level scientific or technical challenges. So we're thinking about different types of mechanisms for working together with BioMade. But for example, if a company in BioMade discovers they have a kind of a critical path, low TRL, that maybe the Agile BioFoundry would be very well situated to help address, then that might be a good example of how we use these resources to collaborate with BioMade. We're also setting aside $1 million to collaborate with investigators that are supported by the National Science Foundation. One of the things that we've been hearing loud and clear from academics is that it's actually very challenging for them to apply for our directed funding opportunities because of cost share requirements, because academic investigators are often supported by federal agencies, including the National Science Foundation. And those funds are really not something that they can use as cost share. So our current concept here is that the National Science Foundation could fund the academic group to do their side of the collaboration. And we would be using portions of this $1 million set aside to work on the Department of Energy Agile BioFoundry side of that collaboration. And then kind of a new thing that we're really excited about is also working together with the Minority Supporting Research and Development Consortium. And this is a slightly different model. It's still getting worked out. But whereas all of these other projects are basically resources or funds that need to be spent within the Agile BioFoundry itself, we do anticipate for the Minority Supporting Research and Development Consortium collaborators that some of these funds might actually go out and be spent at these minority supporting institutions, as opposed to entirely within the Agile BioFoundry. But I think it'd be great, for this listening day, just for people that are participating or thinking about participating in BioMade or NSF kind of PIs, or folks participating in the MSRDC. I think there's some real substantial priorities that we're making to collaborate with these groups in the next year. The other thing to really highlight here is that we've been excited ourselves, but also more specifically now directed by Congress to use a significant portion of our resources towards artificial intelligence and machine learning related projects. So within kind of our internal projects, our target is to have about $6 million spent relating to or supporting AI/ML, and then across all of the collaborations to have about $4 million kind of targeting or being related to AI/ML. So if you are thinking about putting in proposals through these collaborations to work together with us, I would highly encourage you to think how can you best leverage some of these artificial intelligence, machine learning types of approaches as part of your solution to overcoming your challenge. Just because we are going to try to prioritize projects that are going to be leveraging those types of capabilities.